Hello, my name's Bob Willis, and every month we show you how to do it. A number of techniques that we can use. Now, microsectioning is a very common technique. We're basically producing a section of the solder joint and assessing the degree of wetting, the degree of solder spread, the intermetallic formation between the different surfaces being joined. That's one technique. That requires the skill of a metallurgist to produce the microsection and assess the results for you. We can do environmental temperature cycling, where we take a printed circuit board and temperature cycle it within the range that it might actually see in operation. So temperature cycling, let's say minus 55 to plus 125 over 500, 1000 or maybe 2000 cycles. Now again, if the product has been well designed and well built, then we shouldn't see failures. We will inevitably see some damage to the joint, initial crack propagation through the bulk of the solder, perhaps because of mismatch between certain surfaces. But again, that gives you confidence in the joint and reliability. We can speed up this process sometimes by doing shear testing as part of an environmental test program. So we're seeing early evidence of perhaps the effect of temperature cycling on solder joints, on solder alloys. We can also do drop testing, where we see the final failure. So when a solder joint actually does break after 1, 2, 20 drop cycles of the product. Again, this gives us some degree of confidence in the reliability of the solder joint. But it's fair to say that the most common technique is temperature cycling over a specific range and monitoring individual solder joints to failure. Again, there are IPC standards which define what to do, how to do it, but you really need a laboratory with the right equipment to be able to do this assessment for you.